let's look at how we can use the formulas we've learned in some word problem like thing questions. Right, so if rs is equal to 13 and we're told that r has coordinates 3 and 9 and s has coordinates 8 and y, what is y? So very useful, draw a sketch. So r has coordinates 3 and 9, so let's say somewhere up here, and s has, we just know its x coordinate is 8, right? So it could be a point somewhere down here, right, with coordinates s and some y coordinate, and the distance between them, between r and s, is 13. But likewise, it could be a point somewhere up there, and I mean, my scale is terrible, but I just couldn't put it high enough. So the idea is, you know, since all we know about s is its x coordinate, we don't know how far up or down it is. All we know is that the distance between r and s is 13. Right, so we're going to plug this into our distance formula. So the distance between r and s is x s minus xr, and you don't need to write this first, but just in terms of where we're wanting to go, plus ys minus yr squared. Alright, so that's going to be my distance, and we know that the distance is 13. So it's going to be 13 is equal to 8 minus 3 squared plus y minus 9 squared. Okay, and we can square both sides, so we have 169, and all we're left with here is whatever was under the square root. So 8 minus 3 squared is 25, and over here we've got y minus 9 squared. And in fact, let's just multiply it out. So we'll have y squared minus 18y plus 81. Remember that y minus 9 squared is y minus 9 times y minus 9, so you have to do the whole FOIL business, right? And so what that simplifies to is y squared minus 18y, and 81 plus 25 is 106. And this is a quadratic equation, so we're going to try to get everyone to one side, leave the other side as 0. So I'm going to subtract 169 on both sides, and that will give me minus 63, I think, right? And my other side is left as 0. And so I need to try and factorize this. So it's a trinomial. It's going to factorize this 2 brackets. Y is what I'll put down first. Then let's think about 63. The multiples, the factors that come to mind are 21 and 3. And if I make this a minus 21 and this a plus 3, that works out. So y minus 21 could be 0, or y plus 3 could be 0. So y could be 21, so that would be this point up here, or y could be minus 3, and that would be that point down there. So those are the 2 possibilities. If g has coordinates 7 minus 9, and h has coordinates x and 0, and the gradient of gh, the line gh, is 3, what is x? So quick sketch. G is 7 and minus 9, so somewhere down here, and h is x and 0, and so we don't know where it is. It could be there, it could be there, who knows. But what we do know is that it has a positive gradient of 3, and a positive gradient is either positive rise, positive run, so like that, or negative rise, negative run, which still looks like that. So positive gradients, lines with positive gradients climb, so it makes sense that, you know, my h is somewhere over there, so that my gradient can look like that. So let's plug this into the formula for gradient. So the gradient of gh is going to be the y coordinate of h minus the y coordinate of g divided by the x coordinate of h minus the x coordinate of g. So since my gradient is 3 and the y-coordinate of h is 0, the y-coordinate of g is -9, so 0 minus -9, and my x-coordinate for h is unknown, my y-coordinate for g is 7, so I've got 3 is equal to 0 plus 9, so 9 divided by x minus 7. You could solve this by inspection. 9 divided by 3 is equal to 3, so x minus 7 has to be equal to 3, so x would have to be 10. Or you could make both sides of your equation have the same denominator, so my left would be 3 times x minus 7 over x minus 7 is equal to 9 over x minus 7, and so I could say 3 times x minus 7 is equal to 9, x minus 7 is equal to 3, x is equal to 10, right, if I divide both sides by 3 at this point. Or you could multiply it out instead. Whoa. So that would be 3x minus 21 is equal to 9. Add 21 to both sides, so that would be 30, and so x is equal to 10. Whichever way you do it, you arrive at the fact that x is equal to 10. If C has coordinates minus 2 and 4, and the midpoint between C and D is 1 and -3, what are the coordinates of D? So again, quick sketch. Minus 2 and 4 is somewhere here, and the midpoint is 1 and -3, so 1 and -3 somewhere here, right? And so it makes sense that D is going to be somewhere down here, right? And we need to figure out what its coordinates are. So we know that the midpoint between C and D is found by taking the average between C and D's x coordinates and the average between C and D's y coordinates, right? And so we know that essentially -2 plus the x coordinate of D divided by 2 is equal to 1, right? Is equal to that guy. And 4 plus the x coordinate of, not the x coordinate, the y coordinate of D divided by 2 is going to be equal to -3, right? So 1 is just the same as 2 over 2, so that means that -2 plus the x coordinate of D is going to be equal to 2, and if I add 2 to both sides, I'll have the x coordinate of D is 4. And to find my y coordinate, so I'm going to write -3 as -6 over 2, so that means that 4 plus yd is equal to -6, and so yd will be -6 minus 4, which is -10. And that makes sense given where we projected D will be. It makes sense that the coordinates of D are 4 and -10. It checks out with our visual. Right. So you're given P coordinates for P, Q, and R, and you're asked to prove that triangle PQR is right angled. So some of you might already know the relationship between perpendicular lines, the gradients of perpendicular lines. So you could use that if you're aware of what that relationship is. Otherwise, we could use the converse of Pythagoras. So let's start by plotting these points first. So -1, -3 will be somewhere over here. 1, 1 will be somewhere here. And 6, 6, 6, 6 might be somewhere over there. Okay, and of course the question is, have I copied this down correctly? Because wow, this looks wrong. Let's try this again. Right, okay, there we go. The gremlin is found. So the coordinates of P are actually 3 and -1, right? So that would be down here somewhere. And the question is for us to prove that PQR is right angled. And so using the Pythagoras of the converse of Pythagoras, what we'd want to show is that this distance squared plus this distance squared is equal to that distance squared. If we can show that that relationship holds, then we know that this angle is a right angle, and it looks like that's the angle that is the right angle. So that's what we're going to do. So let's work out our distances. So PQ is going to be equal to 1 minus 1 squared plus 1 minus 3 squared, and that gives me 2 squared, which is 4, and this will also be 2 squared, which is also 4, and we'll just keep them in third form, so square root of 8. And then QR will be equal to 6 minus 1 squared plus 6 minus 1 squared, which will be 25 plus 25, and that's equal to the square root of 50. And then finally PR will be equal to 6 minus 1 squared plus 6 minus 3 squared, and that would be 7 squared, which is 49, and 3 squared, which is 9, and that is equal to the square root of 58. So PQ squared plus QR squared is going to be equal to the square root of 8 squared plus the square root of 50 squared, and that gives me 8 plus 50, which is 58, right? And PR squared is equal to root 58 squared, which would just be equal to 58. And since PQ squared plus QR squared is equal to PR squared, that would mean that Q is 90 degrees, right, by the converse of Pythagoras. Right, one more question. If M, which has coordinates minus 2 and 1, and N, which has coordinates x and minus 7, are equidistant from P, what is x? So equidistant just means they are equally distant or equally far from P. So quick sketch once again. Right, so minus 2 and 1 will be over there, and N we know has a y coordinate of minus 7, but as for whether it's here or here or here, we don't know, right? And then they're equidistant from P, so P is has coordinates 1 and minus 4, so that's maybe somewhere over here, right? So N could be somewhere over here, or N could be somewhere this way, right? What we're looking for is an equal distance here as this distance over here. So whatever this distance is needs to be the same as this distance here. And since we know what M and P are, we can work out what this distance is. So we'll say MP is equal to the square root of minus 4 minus 1 squared plus 1 minus 2 squared. Right, so minus 4 minus 1 and 1 minus 2. So that would be 25 plus 9, which is the square root of 34. So we now know that this distance is square root 34, and all we know about N is its y coordinate. So let's find NP. So, well, let's find X really. So we know that the distance between N and P will be given by the formula xn minus xp squared plus yn minus yp squared. And we know what NP is. We know that it's supposed to be this because MP So m is equally far from p as n is from p, so the distance should be the same. So square root of 34 needs to be equal to the x-coordinate of n, which is unknown, minus the x-coordinate of p, which is 1, plus the y-coordinate of n, which is minus 7, minus the y-coordinate of p, so minus 4 squared. And if we square both sides, that's just going to eliminate the square rooting that's happening on either side. So 34 is equal to, and I'm just going to multiply this out in the next step, minus 7 minus minus 4, so minus 7 plus 4 is minus 3, and if you square that, that's 9. So 34 is equal to x squared minus 2x plus 1 plus 9. Quadratic equations, I'm going to get one side to be 0, so I've got plus 1 plus 9 minus 34 is equal to 0. X squared minus 2x minus 24 is equal to 0, and I could factorize that as it's a trinomial, so x minus 6, x plus 4, so either x minus 6 is 0 or x plus 4 is 0, so x could be equal to 6 or x could be equal to negative 4, and so those are your two possibilities. So in this case x is equal to 6, and in this case we've got minus 4 minus 0.